The solution name is continuous Libase. Before starting the presentation, due to the lack of time, I will assume that you have a basic knowledge about the plasma and plasma event primitives. So what is the plasma, how it works, and what is the enter and action, or how can the users challenge if operator publish invalid blocks. So the tokamak network is our project name, rebranding project name is a fully generalized plasma chain framework based on the plasma event. So you just think plasma event is the same thing as the tokamak network. So what is the plasma event? Plasma event is fully generalized plasma motor that can support exactly same function and structure as Ethereum. So you can use the EVM and the smart contract and the Solidity and other adapters like Truffle. So it's really awesome, but there is one problem. It's data availability issue. So this is the reason why it's very hard to build the generalized plasma motor. So we made the solution. So the keyword in here is Libase and escape leakcast. So let me just delete this paragraph. Continuous Libase motor includes the Libase in normal operation procedure of plasma chain. So in case of data unavailability, continuous and periodic Libase enables the users to access safely by submitting escape leakcast. So what is the escape leakcast first? It's like emergency escape leakcast. So you can just think as a same as the exit leakcast, ordinary exit leakcast, just exit. So the important thing in here is the rebase. So what is the rebase? The rebase is basically remining original blocks based on another block. So as a result, the state root and the receipt root of the block, which is the state of the block, could be changed. But the transaction root should be same as before. So as you see in this picture, the NLP3 and NLP5 is rebased based on the URP2. So you can check the same transaction root, but the state of them might be changed. So it's very hard to understand with only this explanation, so I prefer the very simple example of rebase. So what we are going to do in here is rebasing the block 2 based on the escape block. So the parent block of block 2 will be changed. So let's see above one first. In block 1, the state of block 1 is user A has 100 pith and B has no pith. And in block 2, A is sent transaction 1, which is sending 100 pith from A to B. And it'll be success because A has 100 pith in block 1. And after the rebase, the parent block of block 2 is now changed the escape block. You can just ignore what the escape block is. I will explain it later. Just focusing on the rebase procedure. So in escape block, user A made the escape leakcast, which is exiting her OR balance from the chain. So in the state of escape block, A has no pith and B has no pith. And in the rebase block 2, you might remember that after rebase, the block has to have same transaction load. So the transaction 1 is also included in rebase block 2. So, but the result of transaction execution is now different because A has no pith in the escape block. So this is basic example of rebase. So what is the continuous rebase? Continuous rebase is comprised of one cycle and 4 steps. So one cycle is a whole unit of a whole procedure operation procedure in plasma event, and one cycle is comprised of 4 steps. So they are pre-commit, DA check, and commit, and challenge. So let's skip this, just let's get into the point. in the step 1, pre-commit. In this step, operator should mine blocks and submit the transaction load of them. And also, he should broadcast those blocks to users. So you might ask, why should the operator only transaction load? There are 2 reasons for that. Number 1 is block submitted in pre-commit step will be rebased later. So the state load and receipt load can be changed. So we don't need to submit that. It's waste. And why then should operator shoot the transaction load? Then the reason for that is if we know the block body, which is a list of transactions, then you can easily calculate what's the valid state of the block. So in pre-commit step, users can compare the transaction load and the block data broadcasted by the operator. They can check the data availability. And next step is DA check. It's very simple. Users check the DA of blocks submitted in pre-commit step, and if the data is unavailable, then users can submit escape request. And next step is commit. Commit is comprised of 2 processes. So one is process escape, and next one is a rebase. So let's see first the process escape. In this process, operator should mine and submit the escape block, which includes the escape request. So the escape request submitted by users is now applied in this block. And the parent block of escape block is the last rebased block of pre-cycle, which means fully available for users. So that's why it is safe. And after this process, it's a rebase. So in this process, operator should rebase the pre-committed blocks based on the escape block. So you can see this picture. Already 1000, that's the last block of pre-cycle. So there is the escape block first and rebase the pre-committed blocks. So as I said before, transaction load of those blocks should be the same as before, but the result of each transaction execution could be different. And last step is a challenge. Operator can submit invalid blocks in commit step and can withhold the data. But in this case, users can challenge because they all know what the block data is in pre-commit step. So they can challenge in this period. And another important thing is cycle can be overlapped. So cycle can be overlapped if we keep these 2 rules. Number 1 is pre-commit of next cycle can be initiated after pre-commit of current cycle is completed. So let's see this picture. So the pre-commit step of cycle 2 is completed, and the pre-commit step of cycle 3 is now starting. You can check that. And commit of current cycle cannot be started before commit of pre-cycle is completed. So after the commit step of cycle 2 should be completed if we want to process the commit step of cycle 3. So by this, users can always send the transactions in Plasma chain. So let's see the attack scenario. In case of data withholding attack, users can submit escape request in pre-commit step and DA check, so they can safely exit. It's very simple. And in the case of invalid block, users can challenge in challenge period because they all know what the data is. So if the challenge is success, then all subsequent blocks, including challenge cycle, will be liberted. So it's blow up. But this is not a perfect solution because there is pros and cons. The advantage is data unavailability can be solved in plurichannel plasma model, but there are also disadvantages. Number 1 is due to the rebase, we cannot guarantee the instant finality. So malicious users can cancel their transactions by submitting escape request by any reason that can cause bad effect for against the users. And number two is block submission cost has increased about twice because the operator should submit in two steps, in pre-commit and commit. So this is the end of my presentation. If you are interested in the Plasma even more, then you can check the technical paper and GitHub links. And thank you for listening.
Now we have a 10-minute discussion. First of all, sir, please give your thoughts on this presentation.
Yeah, so a couple of questions. So first of all, like in your chart, you show the pre-commit period as being like much longer than all these other periods. But like to make a pre-commit, you only just need to submit like one. So what else is happening during the period?
So you mean the pre-commit step period should be long enough?
No,
Right.
go back to this slide. I think it's like 15 or something. Yeah, this one. You know, like the pre-commit section is like much longer than all the others.
Yes.
So I'm wondering like what's happening during that section.
So in that section, users send transaction in Plasma chain. So the operator mines them and submit them.
Well, like theoretically, users could just always be sending transactions, and then the miner would just like, decide if you're at some point in the cycle when to include them.
So yeah, users can always send their transactions, but after this pre-commit period in this cycle, their transactions will be included in this cycle.
Okay, no, so yeah, okay. Right, it's implied, yeah. But then I guess like there's no reason not to just make the DA check start like right after the challenge period ends, right?
So the reason why DA check is in here?
No, I mean I understand why it's in there. I'm just saying like it seems optimal for the DA check of cycle 3 to start right after the challenge period of cycle 2. You don't even need the space in between.
So DA check of cycle 3 can be started after this?
Yeah.
But this DA check step is for the cycle 3.
Yes.
But
Yeah.
after the pre-commit step?
Right, no, I get that. I'm just saying that it seems like.
But you can extend this period like this.
Right. Yes, that's what I mean.
Yes, that's right.
Yeah. What timeline are you thinking of for these periods?
So most important thing in here is pre-commit step should be longer than the commit period.
Well, I think like the pre-commit step, like basically, if you have these like overlapping cycles, then like it's always a pre-commit step. Like I think what better like the data availability check in the challenge period needs to be long enough.
Yes, that's long. But if the pre-commit step period is long, then the other step period can be long.
Yes. So like, how long were you thinking for kind of like the time between two?
I'm not sure, but I think whole cycle period. Now I think the whole cycle period would be 24 hours. So.
Okay. So this does have the weakness that like you have to wait for 1 day before you get a guarantee that like you state is valid.
Yes.
Okay.
But you can minimize those periods, but it'll be more vulnerable. Yeah.
So when you do a rebase, like I guess the rebase transaction would like actually include all of the Merkle proofs, so it would prove on chain that those rebases are correct, right? Or do you need to?
Can you say that again?
So when you do the rebases, like do you need to include all of the Merkle proofs to prove that the rebases are done, or that the state grid is updated correctly, or do you not need to?
Don't need to. Yeah.
All right, because you can just challenge that as well.
Yes.
Yeah.
Challenge. We use the triple-like verification game.
Right.
So the one that Plasma Leaves team use. Yeah.
Okay. No. This is actually like really cool. It's, like I definitely think there's a really big sacrifice here, which is that like you only have these blocks that get basically you only get a guarantee of safety like after a day. But then like that is it does seem like you get a huge amount of benefit out of it, and it does make like a lot of things much simpler, and you don't need like many kinds of exit games. Yeah. So this is Definitely really interesting. I mean, how far along is it in development?
It's under development, so we are gonna implement this more in this month. By this month, yeah. Yeah, thank you.
Any questions from audience? Any questions?
혹시 질문 있으신 분 있으신가요? 혹시 뭐 비탈릭이 앞에서 이제 질문했던 사항까지 포함해서 같이 질문하셔도 되거든요. 발표 내용뿐만 아니라 이제 질의응답 내에 있었던 것도 질문해 주셔도 됩니다. 다들 비탈릭 다음에 좀 질문하기가 좀 꺼려지시는 것 같은데 편하게 질문하셔도 괜찮습니다.
Can you give any questions to Sir Vitalik? It's a very rare chance, you know that.
아니면 혹시 먼저 조언 구하고 싶으신 것 있으실까요?
Can I ask a question about this more?